Let's go over a couple of practice problems for quiz 4. To start with, let's find the domains for the following functions. F of x is equal to 7 minus 3x. What is the domain of this function? It is all real numbers, which we can write as this interval from minus to positive infinity. The reason for this is nothing goes wrong if you put a number in place of x into this function. That is, there is no division by 0, there's no negative number that's underneath an even-powered root, and therefore you can put any number that you want in place of x. Now, this is not the case for the function g of x. G of x is 5 divided by x plus 3. Because there's a fraction, there is something that can go wrong if you try to put a number into this function. Which one is it? That number is negative 3. If you try to evaluate the function at negative 3, this is 5 divided by negative 3 plus 3, which is 5 divided by 0. If you plug that into a calculator, it's going to give you some type of a error message. This means you cannot use negative 3 for x. Any other number is okay, because no matter what other number you put in place of x, you will not get 0 in the denominator. So how can you express your answer as an interval? You can use any number from minus infinity until you get to negative 3, and then you have to skip over negative 3 and pick up on the other side and go towards positive infinity. I'll use a union symbol to say it is both this interval and this interval. All of those numbers are okay in this function. Here, since I'm using a parenthesis and a parenthesis, it just means we're not using the number negative 3. Lastly, in part C, what is the domain of h of x? Since we have a square root, the thing that can go wrong is a negative number underneath the square root. Now, for what values of x would you get a negative number? I can check to see when this is true. When is x plus 8 positive or 0? Anytime that this thing is either 0 or positive, you can take the square root of that number. To solve this for x, you could subtract 8 from both sides. In fact, x must be bigger than or equal to negative 8. So x itself could be a negative number, but if you put negative 8 in place of x, it simplifies to 0, and you can take the square root of 0. If you choose a number that is smaller than negative 8 and try to put it in place of x, that's when the number underneath the square root would itself be negative. So I want to express this as an interval. This says you're starting at and including negative 8, but then you're greater than it, meaning you're going towards positive infinity. I can write it like this. Bracket negative 8, that means you're starting at negative 8 and including it, and you're only choosing things that are larger than it, meaning you head towards infinity. So this is the answer for part C, this is the answer for part B, and this is the answer for part A. In question 2, we'd like to find the inverse function for f of x is equal to 9x plus 5. So the function itself you can think of as y is equal to 9x plus 5. What does it mean to be an inverse? The inverse is the equation that interchanges the x's with the y's. So if I write x in place of y and y in place of all the x's, this thing is actually the inverse. And that's by definition. An inverse of some equation interchanges the x's with the y's and the y's with the x's. What we have to do now is solve this thing for y. It's a two-step process. I'm first going to subtract 5 from both sides. On the left, we have x minus 5 is equal to 9y. To solve for y, I'm going to divide both sides by 9. And I get x minus 5 over 9 is equal to y. This is the inverse function of this equation here. This is the symbol that we use to represent an inverse function, f to the exponent of negative 1. If you see this symbol, it means you have the inverse of the function you start with. And this is the formula for it. It is x minus 5 divided by 9. And this is the answer for question 2. In question 3, we're going to find the vertex, domain, and range of this quadratic function. G of x is equal to 3 times x plus 2 squared minus 7. To answer these 3 parts from this equation, all you need is just a basic idea of what this equation looks like. I'm going to try to understand it based off of transformations. So I just need a very simple sketch of the function g of x. If I start with the function x squared, so this is the function x squared, how is the function g of x different than x squared? Well, we have this x plus 2, so I know this graph is first going to go, because we're changing the x's, 2 places to the left, to negative 2. Start at 0, and we end at negative 2. So let me jot that down. We're first going to go left 2. The next thing that happens is we're going to scale the function by multiplying the y values by 3. So this graph is going to go 2 places to the left, and then if we triple all the y values, it's going to grow much faster, basically being a more narrow function. So here we're going to multiply the y values. I'll say multiply the y's by 3. That is a vertical stretch. The last thing that happens is we're going to subtract 7 from every single y value. So this thing goes 2 to the left, we stretch the y values, and then drop down 7 places. So we're going to shift 7 units down. So this starting point here first goes 2 places to the left. It then stays here when we stretch it, and then it goes down 7 places. So 1, 2, 3, 4, 5, 6, 7. And the graph g of x will look something like this. Again, I don't have a perfect picture of it, but I just need a good enough graph to answer these 3 questions. So here is g of x based off of transformations of the graph of x squared. So where is the vertex? Well, this point here is the vertex. It first goes left 2. It then does not move when we stretch it because it's at 0 for its y value. And then it goes down 7 places. This point is negative 2, negative 7. So here is my vertex. Okay, next, what is the domain? For this function here, it's a quadratic. The domain is all real numbers. In fact, I'm going to write it as an interval like this. You can put any number you want into a quadratic function. There's no limitation on it because there's no square roots and there are no fractions. So the domain is all real numbers. This graph goes forever to the left and to the right. Now the range is not all real numbers. In fact, this graph has a lowest y value. And you can use the vertex to figure out what that value is. I'm noticing I made a mistake. There should have been a minus in front of that 7. So this y value here is at y is equal to negative 7. The graph is no lower than this. Therefore, the range is where the y values start, moving up. So I can see the range is negative 7, including it, up to positive infinity.